Welcome friends to my YouTube channel Sommo Physics. Yesterday I have told about the variation of G with altitude and depth, and we also derived the working formulas. Now today in today's lecture I shall discuss about the effects of Earth's rotation on G. So let's proceed. Now suppose this is Earth. The Earth is rotating about the ns poles. That is, this is n pole, that is s pole. This is with angular velocity omega. Okay. Now this is the orbit of Earth's rotation. That is, this is the radius of the orbit, which we call small r. Okay. This is the radius of the orbit. This is the orbit whose radius is r. Now we consider a point, say P, here. So this is the center. We connect O and P. Okay. Now the point P is located at theta latitude. That is, if this angle is theta, this is also theta. That is theta latitude. Remember it. The point P is located at theta latitude. Now if you see the picture, then it is clear that there is a force towards the center. Okay. First of all, there is a force towards the center. Okay. That is the first force that acts along PO, and this is nothing but the weight. If m is the mass of the object, then its weight is mg. So mg force is acting along PO, and this, since it is a circular motion, another force acts in the this direction. Okay. And what is that force? What is that centrifugal force for circular motion? This is the centrifugal force acts along PQ. So this centrifugal force will be m omega square r, or simply you can write mv square by r. So these are the two forces acting at point P, and must remember that two forces are opposite. Okay. Two forces are opposite. Now we have to find out their resultant. Okay. So what would be the resultant force? That we all know from vector formula. That is a square, that is m square g square plus b square, that is n square omega to the power 4 r square, plus 2ab, that is 2m square g omega square r. And since these two are opposite, the formula will become cos 180 degree minus theta if they act whole to the power half. Okay. Since these vectors are opposite, the angle become 180 degree minus theta. So if we simplify it, what we get? M square g square plus m square omega to the power 4 r square minus 2m square g omega square r cos theta whole to the power half. Okay. Now if you see this picture, this triangle, then from this triangle, that is, give it a name r. So from this triangle, that is OPR, you can write cos theta. This is equals to small r by capital R, provided this is the radius. Okay. So what will be small r? You can write small r as capital R cos theta. So if you substitute that value, then what we get? M square g square plus m square omega to the power 4 capital R square cos square theta minus 2 m square g omega square r cos square theta whole to the power half. Now just see carefully that this term, that is m square omega to the power 4 r square cos square theta, this is a very small term, so we can neglect this term. Okay. Since this term is very small, we can neglect it. Okay. So after neglecting this term, what we get? M square g square minus 2m square g omega square r cos square theta whole to the power half. Okay. So after simplifying we get this result, because this term is very small, so that's why this term is neglected. Okay, now if we simplify it further, then what we get, let's see. So if we simplify it, or then if we take m square g square common, then what we get, 1 minus 2m square g omega square r cos square theta by m square g square whole to the power half. So if it, this becomes mg, okay, and this becomes 1 minus 2 omega square r cos square theta by g. Okay, now from binomial expansion we can simplify it, and we know it that 1 minus x to the power n, this is 1 minus nx plus n into n plus 1 x square by factorial 2. We know this. So if we simplify it and take only the first term, then we can simply write this half comes here. So this is 2 omega square r cos square theta by 2g. Okay, 2 cancels. So what we get? This is the force. So we get F upon m. This is equals to g into 1 minus omega square r cos square theta by g. Okay, and what is it? This is acceleration due to gravity at latitude theta, that is g theta. This we simply write g minus omega square r cos square theta. So this is the ultimate result, that is the acceleration due to gravity at a latitude theta. This is the working formula. Okay, g theta, this is equals to g minus omega square r cos square theta. Okay, so we have derived this working formula, right? Now by using this formula we can easily tell that acceleration due to gravity is not uniform everywhere. By using this formula we can easily show it. Okay, so let's check. Now we know at poles what is the value of theta. We all know theta is 90 degree, so g theta will become g, that is g. At poles acceleration due to gravity is maximum. Okay, but at equator what happens? What happens at equator? We all know equator theta is 0, so g theta, this must be g minus omega square r. So it is clear that at the poles acceleration due to gravity is maximum, and at the equator it is minimum. So this is called the, this is the effect of Earth's rotation. Effect of Earth's rotation, okay, on G. Okay, this is effect of Earth's rotation on G. Okay, so this is what about the variation of G with different factors, that is altitude, depth, or you can say the effect of Earth's rotation. These are the factors that can affect G. Okay, now we do few problems based on central force and planetary motion. Okay, few important problems we have to do in today's lecture. So let's proceed. Now there is a problem, there is a MCQ that for a particle in a central force field, we have to show that for a particle of mass m in a central force field, we have to show its velocity can be written as v square, this is equal to k upon m 2 by r minus 1 by a. Okay, for a particle in a central force field. For a particle in a central force field. Okay, so how we can prove it? So we know that total energy is nothing but the kinetic energy and potential energy, and we know in case of a elliptical orbit the total energy simply depends upon major axis, which is nothing but k by minus k by 2a. And what is the kinetic energy? Half mv square. And what is my v? That is minus k by r. Now if you simplify it, we will arrive at the result. Okay, that is half mv square. This is equals to, if you take a common, it will become 1 by r minus 1 by 2a. So what will be my v square? V square equal to 2k upon m, 1 by r minus 1 by 2a. Okay, so we can rearrange it in this way, that is 2 by r minus 1 by a. So this is the result that we have to arrive. So this is a problem, important problem, that for a particle of mass m in a central force field, we have to show that velocity can be written in this form. This is simply, you write the expression of total energy, put the different values, and if you simplify it, we will arrive at the result. Okay, so this is an important question. Now we move towards another problem. Okay, we move towards another problem. Okay, how the next problem is, we have to find out the force between the sun and a planet is inverse square. This is our next task. Okay, the force between the sun and a planet is inverse square. Okay, now consider the example of earth, which is rotating around the sun. Okay, so if you take the mass of earth is m and radius of earth is r, and mass of sun is ms. Okay, then we all know that in this case the gravitational force that must be equal to the necessary centripetal force, that we all know. Gravitational force of attraction must be equal to the centripetal force. Okay, that we all know. Now what is my fc? My fc will be m v square by r, provided the radius of the orbit is r. Okay, this we can write. So we can write as m by r, v we can write 2 pi r by t, where t is the time period of revolution. So simply we can write m upon r 4 pi square r square. Now from Kepler's law we know t square is proportional to r cube for circular orbits, but if the orbit is elliptical we can write here a cube. But since we consider the orbit a simple circular orbit, we can write r. So we can write t square equal to kr cube. So substitute kr cube. So what will be the result? 4 pi square by k into m upon r square. So these are constant. So we can write as Fc, that is centripetal force, is proportional to m upon r square. And what is the stability condition? Fc equals to Fg. That means gravitational force can be also proportional to m upon r square. Okay, this you can remember. This gives a name, say equation 1. So gravitational force we can write the proportional to m upon r square. Okay, this we can write. Now we all know that gravitational force is a mutual force. Okay, that we all know that gravitational force is a mutual force. So we have to, since Fg is a mutual force, okay, it will also be proportional to mass of the sun. That is, we can write Fg proportional to ms. So from here we prove that Fg, gravitational force of attraction, is proportional to m by r square, and since it is a mutual force, it will also be proportional to mass of the sun. So what we can write by combining these two? We can write Fg is proportional to mass of sun mass of earth upon r square. So what we can write, Fg, this is equals to g ms into m upon by r square. Okay, so this force of attraction is inverse square, obeys the inverse square law of force. Okay, that is Fg is proportional to 1 upon r square. The gravitational force of attraction between the sun and any planet, here we take the example of earth, is a inverse square law of force. So obey inverse square law. Okay, so these are the two problems that you must have to know. Okay, so in our next class I will discuss about few another problems, and we will also find out that the motion of an object through the tunnel of earth will be simple harmonic. We will also do it in our next class. Okay, so in today's lecture we discuss about the effect of earth's rotation on g, and we do few problems regarding the central force and planetary motion. Okay, so if you don't subscribe my channel, then kindly subscribe it and share it to your friends to get latest updated videos based on higher secondary and BSc physics. Okay, thank you.